Hello everyone. Thanks for joining. I'm Shashank and today we are going to talk about the hot topic, generative AI. In this video, we'll talk about Google Cloud Platform's latest and powerful GenAI model, Gemini-Pro-Vision. This model was launched as preview in December 2023 and is now generally available since mid-February this year. During this video, we'll take a look at what is generative AI and what makes Gemini Vision special. We will take a deep look into some of the capabilities and requirements of the Gemini model. And lastly, we will go through the code execution and steps on how you can interact with the GCP Gemini model within a few minutes. We will use a Terraform module to spin up the required infrastructure onto the GCP and a Python code to interact with the Gemini Vision. At the screen right now, you are seeing all the components that we will be working through to make it work all together. It does include the code side, which is made of Python and Terraform, and on the right side you see the Google Cloud Platform related components. So let's get started. Alright, so what is generative AI? It is a type of artificial intelligence that generates content. Generated content could either be an image, video, code, documents, audio, etc. The generative AI models are powered by LLMs. LLMs, large language models, are deep learning models that are pre-trained on a massive amount of data sets. So, generative AI generates the content by using the intelligence of large language models. All major cloud platforms has their own native LLMs, such as Google has Gemini, Palm, Meta has Llama, AWS and Microsoft has Titan and OpenAI respectively. Gemini-Pro-Vision is spatial because it's multimodal. It means it can process information in multiple forms, including image, video, texts, etc. You may have used some GenAI models where the mode of communication between user and the model was only in the form of text. Say you ask GenAI a question, what is universe, and in turn you will get the answer in text form. However, in the case of multimodal, you can provide the model with an image or video and can ask specific things about it. There can be several use cases. For an example, you can ask Gemini model to extract text from images or scan documents. You can ask a specific question about the details provided in the picture or documents. You can provide Gemini a list of pictures, say posted by your customers, and you can ask it to verify the brand of the product in the pictures and whether the product was broken or intact. I'm sure you can think of several use cases within few minutes. All right, so we are looking at our overall components that we'll be dealing with throughout our demonstration. On the left side, you are looking at the GitHub repository, which has Python and Terraform module. On the right side, we have a GCP project components, which has some enabled APIs, the GenAI model, Gemini-Pro-Vision, GCP bucket, and a service account. So as part of our demonstration, we will first run the Terraform module that will enable our APIs in the GCP project. It will create a GCP bucket, a service account, bind some predefined GCP roles to the service account, and will also export a key JSON file from the SA. The Python module here is a general API request and response based model where we will request the Pro-Vision model by passing it the image URI, which is available in GCP bucket, and then we will expect a response from the model. For the authentication purpose, it will use the key JSON file if our app is running in container and in local. So for the code execution and demo, we will go to the GitHub repository. The URL for this is also available in the description below. Then we will open the readme MD file and let's get started. There are few prereqs like you should have a GCP account and a project. Also, I recommend you look at the GCP authentication methods and identify the best suited authentication method for your use case. For the demo, Terminal authentication through gcloud auth login followed by application auth login would work just fine. However, there are better ways to set up authentication as a workload identity when you are running application in GKE or Cloud Run, etc. For our demo, I already cloned the repository. We'll open a new terminal. Okay. As we discussed, this app has two modules, Terraform to build the infrastructure over GCP and then Python app to run our application against the Gemini model. So we'll start with the Terraform, cd into the Terraform directory, and then update the variables.tf. Over here, we will update two properties. One, the GCP project ID, and two, the key path where we want our service accounts key JSON file to be created. This has to be an absolute path. So first, let's start with the GCP project ID. So from the GCP console, I will copy the project ID and will place it here. And I want my key to be created in my secrets directory in my local. So I'll copy the absolute path and will replace it here. Now, after saving the file, we go back to README and do the Terraform init and create a plan. And we'll also apply the plan. The Terraform apply command would take up to 1 minute or so. Once apply is completed, we should be able to see the key file generated into the directory, and then we can upload our image files into the GCP bucket as well. So for that, we go to GCP console and look for the bucket that has been created for us and upload a folder. For the demo, I have selected images in certain category, so I will go ahead and upload the directory. So once all our images are loaded, now we switch back to README file and then go forward with application execution. So there are two ways you can run this application, one in your local terminal, or you can run your application in container. We will see execution in container fashion. So first we change the directory to our application. And then we'll create a Docker image and update the config.yaml file where we update project ID and also the image URI. And we'll use csv.png file and we'll ask Gemini model to convert the CSV image into JSON object. So we'll copy the URI, place it over here, and then we'll change the prompt to convert CSV image into JSON. You can also influence the output of the GenAI model using properties like temperature, with 0.1 being more predictive answers to 0.9 means more creative answers. You can also set a limit on output tokens. Roughly 4 words account for 1 token, and if you want a precise answer, say in 100 tokens only, then you can just use this range for that. Also, the AI models comes with the responsible AI concept as well, so you can put a threshold onto the type of content that is being processed by the GenAI model. So after saving the config.yaml file, we'll run our Docker image and we'll update the path to config YAML file and also a path to GCP or .json. And we'll run it. All right, so here's the response from model. It has converted the CSV image PNG file into the JSON object. Now, of course, Gemini model can be used for various several purposes. In the second example, I have passed an image with number of people in the car, and the prompt text is, are passengers looking stressed in the car? So say for the security reasons, also we can use the Gemini model, and the response we have received from model is very specific. It mentions all passengers individually in the car and describes the state as well, such as woman in the front seat is smiling, the man in the driver's seat is smiling, and so on with the woman and man in the back seat as well. So after taking all these things into consideration, the model has identified that none of the passengers looks stressed in the car. In another example, say your organization is accepting reviews from customers in form of images as well. You can filter the reviews by asking Gemini model like, what product is this? Is it even my product and brand? And are there any visible damage to the product? When I did it against the laptop image on the right side, the model responded with what brand it is and what is the model of the laptop, which is quite impressive. And it also identified that there is no visible damage to the product. All right, so if you see that updating config.yaml file is a hassle for each request, which it is, then you can also use it as a command line argument, and you can send some variables like project ID, region, the image URI, etc. Through the command line as well. So please go ahead and take a look at this. All right, so lastly, let's end this with some fun facts about the Gemini-Pro-Vision model. Roughly 4 words account as a token in generative AI. So maximum tokens, input plus output, could be 16,384. However, the maximum tokens as an output or response from the model we can get is 2048. From images side, the maximum number of image we can provide to the prompt are 16. The image formats accepted is PNG and JPG. The maximum size per prompt, the text plus image size as well, could be only 4 MBs, and the tokens accounted for each image is 258. So each image you provide to the Gemini model would account for 258 tokens, which will be deducted in this total 16384. From video side, the maximum number of videos you can provide to the prompt or to the Gemini model is just one. The video file formats are these, those are available, and then tokens accounted for each video that you upload is 1032. The number of requests per minute we can send to the Gemini model is 100 requests per minute in US Central 1 region and 60 requests per minute in all other regions. So few things to consider when we use Gemini-Pro-Vision model is, one, in a prompt, consider placing the image before text. If you are using Vertex AI Studio, this is one thing to consider. Also, rotate the images to the correct form before adding it to the prompts. From videos perspective, Gemini model will process the video for first 2 minutes only. Even if you provide Gemini model with a video of 10 minutes, it is only going to process the first 2 minutes. Also, the audio within the video cannot be processed. So if your prompt text is about, in the video, who said what, Gemini model won't be able to answer that part because it cannot process the audio within the video. Also, it is not suitable for medical usage due to it being very critical. It cannot read X-rays or MRIs and so on. With this, we conclude our video. I hope you have got a good understanding of Gemini-Pro-Vision model, and with the code ready, you will get a good head start into the Gen AI world. Let me know in the comments. I wish you happy learning.